So we'll go through it once more for the recording. So let me take for example an EX3. This is like a GPS trail of a 7-day trek somewhere in OG maybe or Venkateswara. Let me generate an elevation profile with this from this GPS log. It takes a bit more time. It's like 1.5 megabyte if you keep walking for 7 days. Let's generate an altitude profile which will show us how we went up and down over the saddles and the peaks. So this gives a nicer idea, right? So here you can see, this will be Venkateswara. You can see this in the sense that Venkateswara, right, is like a long range from north to south. To the east, actually, you're going towards the sea. And if you reach the base there, you'll be at 200-meter altitude. If you start from the Talakona side, the western side of the Karnataka, I mean towards the Karnataka plateau there, you'll see that you're already, even at the base of the hill, you're already at a 550-meter altitude. So we climbed actually towards the base of the hill. Here we started climbing, went over, got into a stream here, I guess. Here again, we climbed over some peak, and then again, we went down pretty steeply to a valley, climbed up, etc. So GPS visualizer as well as GPSs allow you to kind of generate also an altitude profile of your trail, which is very interesting. And then again, as I showed, let's again do it for a bigger trail. We can visualize any existing trail on a Google map, or you can show it, you can generate a KMZ file to load it in Google Earth. So if we load this trail again and show it on top of Google map, you can then see how we walked on top of the satellite view or the terrain view. Loading here. So you need to take down a screenshot because it's like a temporary web page. You cannot really save it or anything. So here this will be in Venkateswara. So we went from east to west. I think I remember this is some 10-day trek actually. 10-day. It's actually I think a 3-day trek. Part of that 10-day trek. So you can see a lot of flags. Many of the flags came from the laptop, where I indicated some points. If you go along the line, I would have indicated some additional points of reference. So you can clearly see how we kind of got into valleys. Kind of follow the stream down. You can see the stream more clearly on the, or very clear. You can then follow it on the terrain map, where you will see right that we nicely walked in the stream. Terrain view is so clear. Once you get used to it, you can clearly see that steep drop of the valley on the northern side, a very nice incline on the southern side. We follow the stream here, stream. Here is a huge gorge where we got stuck. No GPS signal. It's like 100 meter deep, 400 meter long, just 5 meter narrow, so no GPS signal. So we had to climb through the side stream, climb over it. Here we try to get in, not possible to get in. So we're not getting back to the mainstream. Here we're walking on top of the ridge, going up, climbing up, getting on some jeep trail, I think. And then here we're actually following some jeep trail. If you go again to that satellite view, you can see that you can clearly see that jeep trail zigzagging, hairpin bends. We actually were a little naughty. We were too lazy to zigzag, so we just walked directly down the hill. But you can clearly see, right, that Google Maps are clear enough to clearly, and you can clearly notice this is not a stream, this is not a natural thing. This is clearly a human-made thing. It's straight, it's flat, and it's indeed a trail because the guys are smart, obviously. Jeeps, motorable vehicles have to go over this, so you'll never see any steep ups and downs. They will always nicely follow the topo lines. Here it's a bit crossing the topo lines, but they actually zigzag down, hairpin bends. Here again, it's like a very nice incline, so they will always be going on these jeep trails, following between two topo lines because the vehicles cannot climb up steeply, or the buffaloes or the elephants in those times, whatever they used to go over those jeep trails. And this is the place where we got in the hill. So remember that steep peak in the beginning of our elevation profile. This is where we went from 550, 600 to bang, 850. So very nice to really do a little bit of diagnostics post the trek to see what exactly you have done. Okay, so a few more examples here. This is a non-bodybuilder trek, a 4-day trek, where again we overlaid the GPS trail over a Google terrain map. So again, you can see how we went through valleys. We left the valley, the stream which goes straight. We started climbing on the ridge, nicely following on the ridge with awesome views. Set up a campsite, be a little bit below Wambatigudi because there's no water on top. Then we went down through and a nice ridge, right? A very nice slope here, rather than getting down left and right, which is very steep. Go to the slope, hit the stream, try not to get washed away. This was somewhere after the monsoon. Put a rope, get everyone on the other side. Follow the stream again. Ding, ding, ding. Stream is nice. Drinkable water, shade is there. Get into a side stream here. Get to some jeep trail and then again follow ridges to a place called Jenkal Beta, 1,376 meter, which is the highest peak in this Kabinali Reserve Forest. Amazing views, except of course that we were stuck in a mist where we were not able to see 5 meters in front of us. So same examples which we show, right? You can plot your completed GPS trails left or your blind GPS trails right on top of Soviet US Army maps. You can view it in 3 dimensions like we already shown in Google Earth. Very nice to see how you walk through it virtually. Altitude profile is there, which we saw, ups and downs. Yeah, altitude is much more important than actually how many kilometers flat you walked in terms of difficulty. And then all this georeferencing, which I explained. One last thing that I might want to give you as a tip is in case you don't have a GPS, in case you just have, say, a Nokia phone or a very simple tool that gives you latitude and longitude, sometimes very cheap unit, is that you can load you can georeference using Terra Incognita, the terrain maps. You can even put your planned trails on top of it with some reference points. Then you can put a grid on top of this. You can put, for example, a 10-second grid on this, which is 300 meters. You can put, if it's too big, you can put like a 30-second grid, so you have 900-meter cells. And then you can print this out. So you can take a print out. You might have seen that I typically take this along with me on a trek, just in case that GPS runs out of battery or it falls in the water. So then at least you have a grid with you. So if you then switch on your phone and you get the latitude and longitude, you can see roughly in which grid you are here. So in that sense, right, for people who don't have the more expensive GPS units, you can definitely do this print out reference map with the grid, latitude, longitude grid on top of that and take it along with you. It will be very useful also to learn, to learn more about terrain maps. You will get your position on the map and then try to see whether this is indeed the position. You don't even need latitude, longitude. If you have a reference point like a peak here, if you say, hey, you know you're 500 meters to the right of this peak, you can actually easily find out right where you are. Just need to have a bit of a reference point. Sometimes the problem is, okay, we could be walking in valleys or surrounded by heavy vegetation. Here again an example of overlaying that NASA, remember color data, where they use color for heights. Red is high, green is valley. Here I overlaid it with the Russian army maps. So this is very interesting to see. You can see that the Russians, maybe 1 century ago, 70 years ago, were pretty accurate in their manual streams. It's nicely matching with the precise satellite data. Yeah, it looks like a thermal map, but it's not those in those action movies. I just use color for altitude in this case. Right. So that's it a bit. One last point is we have many photographers in our treks. What you can do is most even compact cameras, when you take a photo, right, you get a JPEG file. A JPEG file will contain some metadata, EXIF data, which will include the time you took the photo. So now it becomes interesting because also that GPS that another guy is carrying with you is also keeping track of the time. So now it's possible to start correlating the trail, the location data with the photo. So you can kind of start plotting where every photo is taken on the map. That's what they call geo-referencing or geo-tagging photos. So that's supported in Picasa. If you have a GPX file with a small utility, you can add data to the EXIF data that adds actually the latitude and longitude of each photo. So Picasa can actually show you. It can give you even like a visual trail now, how every location looked, every waterfall, every peak, every viewpoint along the trail, which is very interesting. We don't do this often, but it's a very interesting thing to do, being able to know where every pic was taken. Okay, I think I will stop the recording here.